So the only difference for here today on number 12 is that the denominators are not the same. So let's first look at a fraction that, let's see here, with just numbers. So if you had an old-fashioned fraction like 1 over 2 plus 1/10, right? Review, what are the steps to add two fractions? Well, the first thing was to factor the denominators. So you took anything you could factor. 2 you can't factor, but 10 is 2 times 5. And then you sought to find what do you need to multiply by to keep these the same. So if this has a 5, I need to multiply by 5 over here. So 5 right here, so they're the same denominator, but you have to do the same things at the top and bottom. So we end up with 5 over 10 plus 1 over 10, which is 6 over 10. And then at the very end, you still sought to reduce. Right? And you factor the top, factor the bottom. The top factors to 2 times 3. The bottom factors to 2 times 5. And this is what the quiz you just took was about, canceling those out, and what you're left with was the final answer. So we're doing the exact same steps from 4th grade, basically, but with polynomials. We have to factor the bottom, the denominators, get them to match by multiplying top and bottom until they match, whether it's I have to multiply once, twice, 3 times. We combine the fractions, right? And then factor the top and bottom once again to see if anything cancels out. So basically from this point on is all the review. That's what we've been doing all week, just practicing this, reducing and whatnot. Today is just the only thing new is get a common denominator. But most of it is just, okay, get to this point and do the same thing you did prior to this. Nothing different. So like I mentioned, it's important to already know what we did earlier this week and be on top of that. It makes this a lot easier. It makes it more like a review assignment. And it does ask for the excluded values. So we do have to protect ourselves from dividing by 0. So this just means what numbers in the denominator would make this equal to 0. Okay, so you're looking at excluded values would be when is x squared minus 9 equal to 0? And when is 5x plus 15 equal to 0? Cannot divide by 0, so figure out those numbers. So when is x squared equal to 9? Square root both sides, you'll get plus or minus 3. And you'll notice if you do it on this other one here, you'll get negative 3 again. So that's kind of covered since we already got negative 3 from the first one. So our excluded values are just positive and negative 3. So you can do the excluded values first, last. We're not graphing them, so you're not going to see these vertical asymptotes anymore, but that's basically how they turn up. It could be the removable discontinuity as well, but I don't think we have any on these problems. Okay. So that's step 1. Now we can do this, the sum and difference. So if you're ever not sure where to start and how to start, you go back to this. The first thing we did was factor the bottom. So let's do that first. Factor the bottom. Denominators. So what is x squared minus 9 factor to, and what is 5x plus 15 factor to? All right, so just go ahead and write those down. All right, ignoring the numerators for now, not doing anything there. So we have x plus 3, x minus 3. And over here we have 5 times x plus 3. So we already have one of these in common, but the other ones are not. So same thing we did before, we multiplied top and bottom by 2. So this has a 5. So we will multiply top and bottom on the left by 5. So now these are now in common. But there's still this x minus 3 on the left that's not on the right. So now I'm going to multiply the right side by x minus 3. So just keep going until the denominators match all around. And of course, do the same thing on the top and bottom. Whether it's just a number or it's a full binomial with parentheses, do the same thing top and bottom always. So now I have my denominator. I can write this as a single fraction, same denominator, because they're the same. This is a subtraction problem. Put a subtraction right there. And so, use this pink. So this times this will be right here. And this times this will be right here. Just joining them together. So 5 times 2x is 10x. And then 2 times x is 2x. And 2 times negative 3 is negative 6. Okay. Question?
Why don't you square the x plus 3 and the x minus?
Like multiply these out?
Well, because you have x plus 3, x minus 3, and then you have another x plus 3, another x minus 3. What do you do with the second?
No, it's the same fraction. We're just joining them together. Kind of like down here. They're both over 10. We just make a single fraction with them, like here. Yeah. So we don't need to do anything on the denominators. Okay. All right. So we'll get 10. No, we'll get 8x. Right. 10x minus 2x. And then we'll get plus 6. How come plus 6? Yeah, and that's probably the most common mistake. And I purposely left this off, that you're really subtracting all of this. So to do this properly, I should be putting parentheses here. So it's minus negative 6. That's why this is plus 6. Very easy to miss and forget and put a minus there. All right, and lastly, you see if this reduces. So going back to what we did on numbers only, as soon as we got a fraction that's all simplified, all right, I got 6 over 10. I went ahead and factored the top and factored the bottom. I got 2 times 3 and I got 2 times 5 and canceled out what's the same. So you don't stop there. We still want to keep factoring and see if we can reduce. So can we factor the top at all? Yep. Take out a 2, right? 2 goes into both. So we have 4x plus 3 does factor. And the bottom stays the same. Nice thing about these is that the denominator is already going to be factored. So we had to do that to do the common denominator earlier. Now, does anything cancel out? 2 over 5? Nothing reduces there. There's no 4x plus 3 in the denominator, so nothing cancels out. So that's our final answer. Now, I want to put these kind of problems out here because the past 2 days we've been working on fractions that only reduce. But it's very possible, yeah, at the end of a problem you could get 6 over 10 and yeah, you had to reduce that, but there's plenty of equations you solved and you just got 1/2 and you didn't have to reduce. So we are practicing this not because that has to happen on every problem, but when it does happen, you know how to do it. But it's very possible to get a polynomial rational expression here that does not reduce, and that's the final answer. So it's a little more intensive because you don't have the answers down at the bottom to check to see if you did it right. You just got to rely on, your work being correct. So we'll use that as our final answer there. Okay. So same idea right here. We have x minus 5 and we got an x minus 4. So each fraction is missing the other denominator. So we just need to multiply this left side by x minus 4 top and bottom. And I'm going to multiply the right-hand side by x minus 5, top and bottom. Of course, we do this top and bottom stuff because that way we're technically multiplying by 1 on each side. And if you multiply by 1 in any form, it does not change the answer. It keeps it equal. So we have one common denominator. As soon as they're the same, there we go. We can combine them. This is an addition. And I'm going to put the answer to that part right here, and the answer to this part over here, and then combine them all together. Some of you might be able to look at, distribute both of them on both sides and add them at the same time. Just be very careful if you do that, because you're liable to make a mistake. So negative 3 times x, negative 3x. Negative 3 times negative 4 is positive 12. X times x is x squared. X times negative 5 is negative 5x. And just simplify that top and see what you get. So more of the same on the bottom. Denominator doesn't change. Go. And it doesn't look like we have a whole lot that combines. I mean, do we have a negative? Where'd it go? We do have a negative 3x and a negative 5x, but the x squared won't combine with anything, neither will the 12. So we'll have x squared, and then we'll have negative 8x, which comes from the negative 3 and the negative 5, get negative 8. And then we have the 12. You notice how I wrote these in descending order with the x squared first, and then the x, and then the number, just like we always do. That's the order we're used to factoring in, so it makes sense we would write in this order. Now, we have one fraction fully simplified. Go ahead and factor the top. Does the top factor at all? And if it does anything cancel out on the bottom? And you can see, you probably feel this, that we're pretty much just doing review, what we just did on the quiz right now. This is nothing new, and well, how do you do that, and where does that come from? It's, all right, so to do the same thing we did before? Yeah. What multiplies to 12 adds to negative 8, right? And you end up with, what do you get? Negative 6 and negative 2. Yeah. X minus 6, x minus 2. Anything cancel out? No. Yeah, nothing's the same. So even after all that, we didn't get any common factors, nothing reduces. There's our final polynomial answer. Now we didn't do what are they called? What are they called? Excluded values. We didn't do the excluded values yet, so look at each one of these. What makes each one of those equal to 0? So for here, negative 4, right? X cannot equal negative 4 because that'll make this part 0. Can't divide by 0. And then for this, you can't have a negative 5 because that will make that equal to 0. So our excluded values are negative 4 and negative 5. Notice how I'm using the not equal to symbol here? Because x is not allowed to be negative 4. It can be any number but negative 4 and negative 5. Okay. Let's just do a few more, but it's just more of the same. So factor the denominators here. What do you get on the bottom? And what do you get on the bottom here? Right. Start off by factoring so you can find that common denominator. So okay. Well, you wouldn't be able to do anything if you don't have common denominators. And on the right hand side, what do we get? 6 minus 1 is 5. 6 times negative 1 is negative 6. All right. But, of course, we have to do the same thing on the top and bottom, so we're not quite finished. What's missing and where? All right, so we already have these the same. So on the right-hand side, we are missing an x plus 1, and on the left-hand side, we're missing the x plus 6. So now we have all three factors are exactly the same for both, multiplied top and bottom for any that we're missing. So we got single denominator, x plus 6, x minus 1, x plus 1. Now these could be in any order, by the way. This is not the set correct way. If you put the plus 1, minus 1, then plus 6, doesn't matter. You can move around multiplication. You can commute multiplication, which is why they have the commutative property. 2 times 3 is 3 times 2, so it doesn't matter. This is addition. So we'll just multiply these two on top, put those here, and then these two on the bottom, and put those here. Now, there's two terms in front of this binomial. So normally if there's one term, you just do, this times this times this, but since there's two, we have to do this times this and this times this. 4 multiplications total. So x times x is x squared. X times 2 is 2x, and then 6 times x is 6x, so the 2x from the outside is multiplying, and the 6x from the inside is multiplying, give us 8x. And then lastly, we have 6 times 2, which is 12. Basically, that's the opposite of factoring. So if you look at our answer, if you figured out what two numbers multiply to 12 and add to 8, you would get 6 and 2, and that's where we started. And just do the same thing on the right-hand side. X squared plus x minus 6x gives us minus 5x. And then negative 6 times positive 1 is negative 6. And if you factor this, what multiplies a negative 6 adds a negative 5, you get negative 6 positive 1. Okay? And now we can just go ahead and combine everything that does combine. So the x squareds combine, 8x minus 5x, and then the 12 minus 6. So x squared plus x squared, how many x squareds do you have? 2x squared. 8x minus 5x. And 12 minus 6. There we go. And then see if that top factors. Now, before we started, I did a review on how to factor when there's a number other than 1 in the front, is for this reason. So you can look at this and know how to attempt to factor that. Now, good news for us, especially given the time we have left, if you try to factor this, what multiplies to 12 and adds to 3? Nothing, right? So it doesn't factor. So you don't have to worry about anything after that. So it's actually a little bit faster when things don't factor, and we can just say that's as much as we can do. What are the excluded values? So what makes this equal to 0? And what makes this equal to 0? Yeah. So make sure you do it for each one. Cannot equal these three numbers. Now, if you're interested, you can put this in decimals and see what the graph looks like, and you'll see 3 vertical asymptotes, as opposed to just one that we have been graphing. Okay? All right, I'll leave you with that, and you have the assignment. We'll see you on Monday. Okay, one more here. So we factor the factor the denominators of both. So we'll have x plus 2, x minus 2. And over here we'll have 2 times x plus 2. All right. Find what's missing of the denominators. So on the left side we need a 2, looks like, to match this 2. On the right hand side we need a x minus 2. And now they do match. So we have a single denominator of 2 times x plus 2 times x minus 2. Okay. All over 2x plus 2 minus, now be careful, this is negative 5. So we have negative 5 times x, and negative 5 times negative 2 is positive 10. So let's combine like terms. 2x minus 5x, which is negative 3x, and 2 plus 10, which is 12, all over. And finally, factor the numerator just to see if we have any common factors. And I don't think it looks like we do. Yeah. All right. All right. And then lastly, don't forget the excluded values. What makes this rational expression equal to 0 in the denominator? So for here, x cannot be negative 2 because negative 2 plus 2 would be 0. Can't divide by 0. And for here, x cannot equal positive 2 because 2 minus 2 would be 0. There we go. All right, so those are our 4 examples. And there we go.